this tutorial will show how to use the rule of arrow in, the second version, in the ProofLab. Now, the second version of arrow in is usually applied using going forwards because you use it when you have the consequent and you just want to derive the conditional. So I'm going to show you how it works going forwards, but it can actually also be used working backwards, and I'll show you how that works too, because it's kind of cool. Alright, so first let's look at what we need to do here. So here we have a conditional. It has a big messy consequent, F and T and L. And that looks really complicated, certainly not something we have off the bat. However, it is something we can get. So that's what we're going to aim for. We can't make it a goal per se, but we can just have it in our mind as a goal. So we're going to need the pieces F and T and L. Well, we can get L right away by and elimination from line 1. So we'll do that. And once we do that, we see that we can get T from line 2 by arrow elimination. And then we can use that T to get the F that we need from line 3 by arrow elimination. Then we just need to start putting things together. We need to put them together in the right order. So first we need to build T and L by and introduction. And then we need to build F and T and L by and introduction. Okay, so now we're ready to do our arrow in step. We have the consequent of the conditional that we want. So here's the way it works. You click on the formula, you click on the rule of arrow introduction, and it'll say, okay, this is going to give you some conditional with F and T and L as the consequent and something as the antecedent, and you're going to need to specify it. So once you click apply, then it will tell you to enter the antecedent. So in this case, it's really easy. It's just P, and you can either click OK or you can actually just hit enter. And there we go. So you see, it's justified by the rule of arrow introduction using line 8, which is the line that contains the consequent. Now let's work this proof backwards and see how it works. So what I'm going to do is I'm going to reset the proof. Yep, I want to do that. Okay, so let's suppose that we didn't see right off the bat that the consequent F and T and L was something we could have. So we started out as if we were doing version 1. We clicked on the conditional we wanted, click on arrow in, and hit apply. Okay, so it starts out with an assumption of P, and it wants us to get to this consequent. Okay, so we start working towards that as our goal. Now we have our consequent as a goal. We could even work it backwards. We could say, okay, we want to get this by and introduction. Okay, so what we need is F, and we need T and L. Well, let's say we're going to need to get this by and introduction. Okay, we can get L. Watch this. It's cool. Because we got it. Oh, that made it a little confusing. We'll see how it works. Let's see if it fixes itself. Probably not. Okay. All right, you're going to get a lesson on how to make boxes hot. There'll still be another tutorial that will focus specifically on that. But I want that L to be here. I don't want it outside the box because otherwise I'm going to still have it as a goal. So that's awkward. So I'm going to make this box hot, and you do that by clicking on it. If I want to make it unhot, I click on it again. Okay? So I click on it. Then when I do and E right on line 1, the L goes in the box, and it goes down here, and that's fine. Okay, so then we need to use that L to get the T. Now that may seem problematic because the T is up above the L, and we all know that's wrong. So let's watch what happens. Oh, it's being all pewy. Well, let's just see what keeps going. Let's see if this one goes away eventually, because we really don't need it. We have it here as a goal. See, it's not really behaving itself. Well, we can delete. I didn't have a line I specified. Let's delete this goal, this line. Delete that line. Yes, I want to delete it. Did it do it? Oh, it can't, it doesn't like that. You know what? It's being pewy because I was being smart and starting to work backwards. I'm just going to start over. Okay. So we were fine up to this point, and then I got smarty pants. So I'm not going to try to say how I'm going to get this. We know it's going to be by and introduction, but let's just start getting our pieces. So, and E left. Now it doesn't matter that those pieces are outside the box. But let's get some of them to go in the box. Just 'cause. Okay, so now we want T and L. Okay, then we're going to complete the last step. We're going to get this by and introduction. Oh, I thought that when you did this it would make the assumption go away. It doesn't. So applying it backwards doesn't do any harm, but it makes your proof longer than it needed to be, namely 1 line longer. You've got this assumption that you didn't really need. I thought that it made that go away. I thought it was that smart, but it's not. But it still works. So if you don't see, if there's a proof where you can just get the consequent directly, and so you could use version 1 of arrow introduction going forwards, and you don't see that, and you happen to just work it backwards because that's just how you approach conditionals, that's fine. It'll work just fine. So that's how it works in the ProofLab.